To write a ladder logic program from a narrative description, you first determine what outputs you need. In this case, there is only one output, the motor contactor. The next step is to determine when you want the output on. From the narrative description, in this case, you want the motor contactor to be on when PB1 is closed, and PB2 is closed, and the sensor is closed. Since all three switches should have continuity when the input switches are closed, you will use examine if closed instructions. Since the narrative wants the output to be on only when all three conditions are met, you would connect the instructions in series to perform the logical AND function. In this simulation of the drilling process, the motor contactor will only be energized when the sensor is closed, indicating a part is present and both push buttons are pushed. Sometimes the narrative for a process might require you to use your experience in addition to the information given in the narrative. In this description for an automated garage door, you will need two outputs. One, a motor control that will cause the door to go up, and a second motor control that will cause the door to go down. Looking at the panel to the left of the door, you are also going to need three outputs for lights. One light will indicate that the door is fully opened, the second two indicate that the door is fully closed, and the third will indicate that the door is somewhere in between. For inputs, there are three push buttons: open, close, and stop. There are also two limit switches. LS1 indicates that the door is fully open, and LS2 indicates that the door is fully closed. In this example, contacts on the down limit switch LS2 close when the door is fully closed. The contacts on the up limit switch, LS1, are held closed unless the door is fully open. To understand the ladder logic, read the rung from right to left. An easy one would be the rung for the door open light. The door open light will be on when the up limit switch is open. Try this for the other rungs. Note that interlocking has been included to prevent the door from reversing direction without stopping first, and interlocks to prevent the motor up from being energized when the door is fully opened, and to prevent the motor down from energizing when the door is closed. Pressing the open button energizes the motor up, and the door opens until it reaches its upper limit. Pressing the close button energizes the motor down, and the door closes until it reaches the bottom limit. The direction of the garage door can be reversed, but it has to be stopped first. The ajar light is on whenever the door is not fully open or not fully closed. The narrative for the filling operation requires that when the process is started by pressing the start push button, the conveyor will run. When a box breaks the beam of the photo switch, the conveyor is stopped, and if the box is not full, the solenoid will open the hopper to fill the box. When the level switch senses the box is full, the hopper will be closed and the conveyor restarted. This is the PLC ladder logic for the filling operation. The run light will be on whenever the start button has been pushed and the stop button has not been pushed. The standby light will be on whenever the run light is off. The full light will latch on when a box is present and the level sensor detects the box is full. It will stay on until the box moves away from the photo sensor. The motor will run when the run light is on and either the photo switch is not closed or the full light is on. Observe the simulation of the continuous filling operation. When the prox sensor, which has replaced the photo switch in this simulation, detects the presence of the box, the conveyor stops, and if the box is not full, the solenoid valve opens the hopper to fill the box. When the box is full, the conveyor is restarted. The fill light on the panel represents the standby pilot light.